In this video, we're going to look at exponential regression, specifically using the TI graphing calculator to complete a exponential regression. Okay, so I'm going to use this example that I've used for some of my classes. And this table shows the cost of college tuition for all four-year public and private colleges from 1980 to 2010. First thing I want to do is produce a scatter plot of the data. Okay, so we're going to use the graphing calculator to produce a scatter plot. So we're going to go to Stat, Edit, and in L1, we're going to put the X values. Notice I've already entered my data into the calculator. To enter the data, first of all, let me back up and say, I'm not interested in finding the cost of college since year zero. I'm more interested in finding the cost of college since 1980. So I'm going to let my T represent the number of years since 1980. So for that, 1980 is the year 0, 1990 is the year 10, 2000 would be the year 20, 2000 is the year 24, 2008 is the year 28, and 2010 would be the year 30. So my years, notice, are X equals 0, 10, 20, 24, 28, and 30. And my Y values, I entered the cost of tuition for each year, 3,500, 7,602, 12,922, 16,510, 20,409, and 22,000. Okay, so this is the approximate average cost for all four-year public and private colleges over those 30 years. So to produce a scatter plot, right here above the Y equals, we're going to go to second stat plot. We have a list of options. The calculator will handle up to 3 different options at the same time, or plots. We're going to use plot 1, and I can either press enter to select the 1, or I could have just pressed the number 1. First thing I'm going to do is I'm going to press my enter when my cursor is on the on button, and that will turn the stat plot on. Before I go any farther, I'm going to go to Y equals, and notice that up here above the Y1, that plot 1 is darkened. A little bit of a toggle switch here. I can turn this off. What's going to happen is very often students will bring their calculator to me after having done a scatter plot and will tell me that the calculator won't graph. Typically, there is a problem with the stat plot. So notice if I go back here and press enter, that's off. I went back to scatter plot. Notice that my stat plot, the plot 1 is off again. Okay, I can turn that on and off in either place. So I can turn it on. The first option here is the scatter plot. So I'm going to leave that there. The default is that my X list is in L1, my Y list is in L2. In other words, my X values are in L1, my Y values are in L2. I could select whatever mark I want. My personal opinion, I think the squares tend to be a little bit too big and get in the way. The dots tend to be a little bit too small or difficult to see. I like using pluses, so I'm going to use the plus. Color, you can change the color if you want to. It doesn't really matter. Okay. Now, if I just press graph, I may or may not see the plot. Okay. So real quick, zoom 6 is the standard window, and that's normally how our calculators are set, from -10 on the x-axis to 10, and on the y-axis from -10 to 10. And so notice we're really not going to see much of that data from -10 to 10. I could try to go set my window, or I find the easier way is go to zoom and select number 9, the zoom stat. So I select number 9, zoom stat, and I have my scatter plot. So there I've produced the scatter plot using the TI-84. For my students, what I will tell them is if I want them to draw the scatter plot, it's kind of, if I want a perfect picture, I'm going to use my technology, but I'd say that, that scatter plot looks fairly reasonable. But again, for me, in my personal opinion, there is no scale on the x-axis and there is no scale on the y-axis. If you now press window, you can see that our x-min is going from -3 to 33. I might just say, let's go from x equals 0 to x equals 35. And then we've got a y min of 35 and a maximum of 355 and just over 25,000. I think it's close enough to say we're going to go from 0 to 25,000. That puts some scale on the x and y axis, and it gives me some frame of reference. Okay, I just simply press graph. I'll go back to that scatter plot, and I see the data. Okay. In this lesson that I do with my class, I tend to ask, is the linear model best for this data? Why or why not? And there's two ways I can see it. One, if you notice it, this data appears to curve. Okay, so since the data appears to curve, a linear model is probably not going to be very good. That's one way I can recognize that. Okay, another reality is, remember that for the linear model, we would find a constant rate of change. So in the first 10 years, notice that we see an increase in the cost of college of approximately $4,100. In the next 10-year interval, we see an increase of approximately $5,300. Be careful now. In the next 10-year interval, we see an increase of $11,100. And so since that increase is not consistent, we would also expect that the linear model is not very good for the data. Okay. Now, part C, if I want to find an exponential model for this data, this is why you're watching the video. How do I do an exponential regression? Very simple. Stat, calculate. Okay. Number 4 is a linear regression. Number 5 is a quadratic regression, cubic, quartic, and so on. If we go down to option number 10 or 0, exponential regression. Okay, so we're going to select 0 or exponential regression. We're going to verify that the X list is in L1 and the Y list is in L2. Frequency list, we don't need to worry about that in this problem. Store reg EQ. If you're not familiar with that, this is the regression equation. If I press alpha and then select F4 from the trace button, we pop up this menu here, Y1, Y2. I'm going to select Y1, and then we're going to calculate. So our exponential function is y equals a, which is 30,769. I'm just going to round to the nearest dollar, times 1.0625 or 1.063 to the x. Okay, so that's my exponential regression. Now, remember I did that store reg EQ. If I press y equals, notice that we put the regression equation into y1. And so that's there. So now if I press graph, not only do I have the scatter plot, but the graph itself is always showing up. Okay. Does the exponential model fit the data better than the linear model? Why or why not? Yes. For right now, for this video, for this place, it's because the data is curved. This function follows the curve of the data better. And also, we tend to increase the cost of college at a percent. Okay. Now, as far as a percent increase, notice that this multiplier is 1.063. If I change that to a percent, would be 106.3%, which means the cost of college this year is 106% of the cost of college last year. If I subtract 100% from that, we get 6.3%, and that would indicate that since 1980, the cost of college has been increasing an average of 6.3% per year. This is pretty astronomical. Okay, so let's look at part E here, right? We're going to use the regression model to estimate the cost of college in 2020. First thing I'm going to do is rewrite my equation, since I circled it a bit up there. So 3769 times 1.063 to the x. Again, college has been increasing at approximately 6.3% per year. So if I want to use the regression model to estimate the cost of college in 2020, remember that t is equal to the number of years since 1980. And the year 2020 is 40 years after 1980. So if I want to find the prediction of the cost of college in 2020, and again, this is last year, but y would equal 3769 times 1.063 to the 40th. Okay, a couple ways to do that. So let me show you this on the calculator, since this video is intended to show you how to do things on the calculator. We could go to our home screen and do 3769 times 1.063 to the 40th power, and that would be approximately 43,400 and let's call it $7, since we're rounding to the nearest dollar. Okay, now that's not so bad. What I don't like about doing that way is that the 3769 is a rounded value and the 1.063 is also rounded. So if I go to my graph, okay, one thing I can try to do is, notice here it says calculate, second calc, and number one is value. So we could put in an x value of 40, and the calculator will calculate this for us. First of all, let me say, what if we put in 25? Notice we would get a value of 17,158. If we put in 29, we get another estimated value. So if I put in 40, and let me not do it from here, let me go remind you, second calculate, select number one, the value when x is 40. Notice the calculator kind of screams at me a little bit and says there's an error. That's an invalid number to attempt. Okay. What error did I make? I attempted to use a variable or a function where it is not valid. The reason that's not valid, let's select number two. If I go to my window, see my X max, when I did that zoom 9, my X max is 33. So I'm putting a value in for X or for T outside of that range. Okay, if it's outside of the range on the Y, the calculator is okay with that. If it's outside of the range on the X, the calculator is not okay with that. So if I want to put in a value of X, T, that's bigger than 40, or 40 were bigger, my X max has got to be bigger than 40. Let's just make it 45. So all it does is kind of shift the graph a little bit over to the left. I can see farther to the right. So now, second, calculate the value when x is 40. Okay, I get a value of 42,605, 42,606, 42,606, and I like that value 42,606 better. Not only because it's $800 cheaper, okay, but because, remember, like I said, this 3769 was a rounded value, and that 1.063 was also a rounded value. I prefer not to use rounded values. Okay. Now, another way that I could have done this on the calculator is above graph in blue, it says table. If I go to second table, I can put in values for X. Now, your calculator may not have shown a blank list here. The reason mine does is because if I go to second table set, I leave my independent variable set to ask. So if yours is not on ask, okay, the default is that this would be on auto. If yours is on auto, change that independent variable to ask. And now when you go to the table, it will be blank. Now I don't have that problem of my window being set correctly. I can just put in X is 40. And there's my 42,606 again. Okay. Now again, I'm going to leave my calculator there. I can do another estimate here just because I'd like to do this with college students, kids that are, around 20 years old or so. Use the regression model to estimate the cost of college when you will be sending your oldest child to college. For me, at the time I'm making this video, my youngest is 20. He's already in college and pretty much taking care of things on their own. But my daughter actually had a child a month ago. And so my granddaughter, we'll call her Addie since that's her name. My granddaughter, now a month old, I'm thinking about when I talk with my daughter again soon, hopefully, I could tell her, do you realize that you'll be sending your daughter to college 19 years from now? 18 years from now, let's say 18 years from now. Well, 18 years from now, forgive me for that, 18 years from now will be the year 2039. So my granddaughter, if things go as normal, she'll be graduating from high school in 2039. And in that case, T would equal 59. If nothing changes, if the cost of college continues to increase at that rate of 6.3% per year, what would my daughter expect that she will be paying for my granddaughter when she goes to college? Well, that's going to be to the 59th power. Again, if I'm going to do some financial planning here, let's not use the rounded, let's use the unrounded, especially since if I go back to the calculator, I can just enter 59 at this point. $134,827 would be the projected cost of the first year of college when my granddaughter goes. So there's a little scary, perhaps, look at exponential regression using the graphing calculator.